Welcome meteorology students. Today we're going to cover a video and notes that will explain how clouds get their name. We've done a little bit of cloud identification. I want to prep you for tests and quizzes and for going outside. You should at this point have your own student cloud chart, one that you created using a couple pictures for each cloud type on the internet. And then you should have also completed the cloud identification worksheet, which includes this picture, get used to this one. It's the same one that's going to be on your quizzes, the same one that's going to be on your tests. You're going to see it multiple times. These are the 10 cloud types that you are on the hook to identify. I'm going to walk you through basically how they get their names and teach you a couple tricks that I think will help you out. Okay, first off, let's start with the upper level clouds. These clouds are high enough up in the atmosphere that they are not made out of tiny water droplets. They're made out of tiny ice crystals. So I want you to know the word cirro or cirrus is Latin for to curl. These are wind-blown wispy clouds. You can see the curls right here. And these clouds that are like cirrostratus that cover the whole sky, very thin. You can see blue sky through them. They don't cast shadows on the ground. They don't cast shadows, and they let plenty of light through them. So the first one with these characteristic curls, that's a cirrus cloud. Two is a cirrostratus cloud. Okay, cirro because it's high up, and stratus because it spreads in a layer. More on that in just a minute. And these are cirrocumulus clouds, number three. Cirro because they're high up, and cumulus because they bunch together like cotton balls. More on that in a second as well. These are our three upper level clouds made out of ice crystals. Middle level clouds, 4 and 5. Notice that we have some similar shapes, okay? To this cirrostratus cloud, number 5 is also stratus-like because it's spread out in a layer. Stratus is Latin for to spread out in a layer, not meaning to separate, but to spread out, cover huge portions of the sky. And cumulus means to pile or to heap, which is where we get kind of our cotton ball-like shape. So number 4 is alto because it's middle level, and cumulus because of these cotton ball shapes. Number 5 is alto because it's middle altitude, and stratus because it's spread out into layers. Okay, so altocumulus and altostratus. Our lower level clouds, these three right here, 6, 7, and 8, follow a similar pattern for the most part. Notice how 6 is lower level, but it has these little cotton ball type shapes. And so for number 6, we have strato because it's lower, and cumulus because of the cotton ball-like shapes. Number 7 is a lower level cloud, but it is spread out into a layer. So technically, this might have been called stratostratus, right? But they just simplified it to a stratus cloud. The lower the cloud, the thicker the cloud tends to be. It will let less and less light in. So 7 will let much less light through than 5. And 5 will let less light through than number 2. The higher the cloud, the thinner normally, and the lower the cloud, the thicker it is. Now this last one, 8, really the only difference between 7 and 8 that you can see from this picture is 8 is darker in color. Darker in color comes from the fact that less light is getting through it because not only is it a lower level, thicker cloud, but it contains precipitation. It will most likely rain or snow or sleet or hail on you. And so, excuse me, the word nimbo or nimbus suggests that there's going to be some form of precipitation, not always rain. So 8 is a nimbostratus cloud. The last two that we have, 9 and 10, are clouds that have vertical growth. These are clouds that don't necessarily stay in one level, and like 10, can stretch through multiple levels where the other clouds are located. Number 9 is one of the most famous clouds. These are cumulus clouds. Okay, cumulus, to pile or to heap. It's a cotton ball type shape. If you've ever looked at the clouds outside and noticed that they look like shapes and that they're floating by and there's not bad weather, you're probably looking at a cumulus cloud. As compared to number 10, which is a cloud with huge vertical growth. Look how high this cloud will build. As a matter of fact, number 9 can eventually turn into number 10. It's possible. This is a cumulonimbus cloud. There's that word nimbus again, right? These are also called thunderhead clouds, and they are incredibly huge, tons of energy, and almost always bring about some form of storm or precipitation. All right? All right, continuing on. We made a cloud in a bottle not too many classes ago at the very beginning of this unit, and I asked a question that we never really came back and clarified. I took a match, I lit it, and then I blew it out, and I placed it in a bottle of warm water, and then I would squeeze the bottle and let the bottle decompress. I'd squeeze it and I'd let it go, and this cloud started to form. And I asked the question, why the match? What's the purpose? Some of the most common answers were, well, heat from the match caused the cloud to form. It didn't. It really didn't at all. What we needed was the smoke. And here's why. Clouds, in general, are made up of water droplets, which are liquid, or if they're high enough up, they're made out of ice crystals, which are solid. Those cloud droplets form through condensation. When gas in the atmosphere turns to a liquid, right? It condenses. The trick is condensation is a phase change that requires some solid surface. Okay, condensation just won't happen out of thin air, right? It actually needs some solid surface to form on, like dew forming on the grass, or on a car, or on a bench, or on you, right? There has to be some surface. So what's the surface way up in the air that these cloud droplets are forming on? We call them condensation nuclei. Okay, nuclei just meaning the plural of nucleus. These are tiny particles of junk that float around in our atmosphere. And on those tiny little particles, water droplets can begin to form billions and billions of times, and that's what forms the clouds that we see in the sky. So some example of condensation nuclei, which is a really fancy name for tiny particles of junk that are floating around in the atmosphere. Really small particles of smoke or dust or pollen or salt spray from the ocean, even bacteria particles or ash from volcanoes can be floating around in our atmosphere and can allow for condensation to begin to collect on the outside of them. So every tiny little cloud droplet at its center or at its core has a little tiny bit of junk, right? Little microscopic little pieces of junk floating around in the atmosphere, and that is what cloud droplets actually form on. So why the match? We needed smoke droplets in the bottle. Okay, that's for basic cloud formation and